In this video, I will cover solving trigonometric equations. Specific objectives of this lesson are using standard algebraic techniques to solve trigonometric equations and solving trigonometric equations involving multiple types of angles. Okay, so first off, in order for us to be able to solve trigonometric equations, we're going to use some of the standard algebraic techniques that we learned before, such as collecting like items, like terms, solving, or factoring. Your goal is basically solve and isolate the trigonometric function on one side of the equation. It's almost like how we would solve for a variable like x or y. So you isolate your trigonometric function on one of the sides. So for instance, to solve the equation 2 times sine of x equals 1, we're going to isolate sine. So that's why we would divide 2 to the each side, and then we would get sine x equals 1/2. That's what we mean by solving for trigonometric functions. And so what you would do next in that case is now you need to find x such that sine is equal to 1/2, right? So what x's will give you, what x's for sine will give you 1/2. In other words, x is your input. So what should your input be or angle be so that the value or the output is 1/2? Value or the output is 1/2. So that's what you're going to be investigating for the most part for this topic. So then for that, I'm going to refer it to the sine function and its graph. So you guys notice the sine function has this kind of wave attitude, and we know it's always going to go from -1 to +1 because we know that any sine x is always going to be in between -1 and +1 because that's its range. And so what we're interested in though is sine function, where does it become 1/2, right? And so you guys notice with these red dots, I'm realizing somewhere around this area, it's always going to be 1/2. Same on the negative side and positive side. And so I'm investigating what x will give you that red dot, or the second one, or this one, right? Like what x is this guy? And so the way we find that is we know that the angle pi over 6 always gives you 1/2. So you can take a look at your unit circle and determine what angle gives you 1/2. So then if you do that, you're going to realize it's pi over 6. But then you guys realize that is not going to be the only one. There's going to be multiple x's that gives you the same output. And so 5 pi over 6 will give you the same thing, right? So it's always going to give you that 1/2 value. Again, the reason for that is sine function is periodic. It repeats the same behavior. For that reason, we have multiple x's giving you the same output, in this case, 1/2, right? So multiple x's will give you the same output. So mathematically, the way we write that is a little bit particular. The way we write that is going to look like x equals pi over 6 plus 2n pi, or 2 pi n. Sometimes people write it as 2 pi n, and it doesn't really matter. It's the same thing. Or we're going to say 5 pi over 6 plus 2n pi. So this is what we call a general solution for trigonometric equation. So you may be wondering, what is n? What is n? Well, here's the thing. Because sine function has the period 2 pi, and you guys may recall period means one full cycle, right? Like one full behavior of this function. So for sine function, one full behavior would be something like going from 0 to 2 pi, right? 0 to 2 pi. And then all the others will repeat the same behavior, right? Like when we go further on the right side, it's going to repeat. When we go further on the left side, it's always going to have that same kind of attitude. So this is what we call one period. And because trigonometric functions are periodic, they always repeat the same thing. For that reason, their solutions look a little bit complicated. And then that n represents the number of cycles. So what you're doing is you're finding x such that it solves the equation, and then you're adding this piece 2 pi n or 2n pi to represent more general solutions to it. And so n represents number of cycles on that trigonometric function. Okay, so for instance, in this first case, if n is 2, what I mean by that is it's going to be adding x equals pi over 6 plus 2 times 2, because n is 2 now, 2 pi. What does that mean? It's going to make it 4 pi, right? So pi over 6 plus 4 pi. So what I'm essentially doing here is I'm finding the x when we have two cycles, right? So like when I repeat the same behavior twice. So because I'm adding 4 pi, that represents 2 cycles. And that's what it means. So n is always number of cycles. If n is 5, then you're finding 5 times 2 pi, which is going to be 10 pi, and that'll give you whatever x value that is after 5 cycles for the same function. So here we explain all that in words. So if you like to take a look, you can read it in detail. All right, so I'm going to go ahead and take a look at an example. So example 1, we're going to solve this equation that has trigonometric functions in it. There's multiple. So there's one on the left, sine x plus square root of 2 equals negative negative sine x. So we're going to go ahead and solve for x. So we need to find x's that makes this equation true. So first thing we're going to do is we're going to isolate the sine x on one side of the equation. So then what we can do, it is multiple, but I guess the easiest would be sending this negative sign to the left-hand side. For that, we're going to add sine to the both sides, add sine to the both sides, and then you're going to get sine x on the left plus root 2 equals 0. Then what we're going to do is you're going to isolate for the trig function. So for that, we need to send root 2 to the right-hand side. So then subtract square root of 2 from both sides, and then you'll get sine x plus sine x equals negative square root of 2. So what you're going to do is then combine the like terms, because sine x are like terms. So one thing I need to mention is that you can only combine if they have the same angle. So you cannot combine if it was sine x plus sine 2x. You cannot combine this one because the angles are not the same. The angles must be the same. And also the function must be the same as well. You can't just go ahead and do sine x plus cosine x. You can't combine these two because they're not like functions. They don't look the same. So because in this case we have two sines, you just combine it like this and then isolate it. So divide by 2, and then you get sine x equals negative square root of 2 over 2. Great. So are we done yet? No. We need to find x's, like specific angles. What angles are going to make the sine function become negative square root of 2 over 2? Well, you may be thinking about looking at your unit circle, which is a great insight. So you can take a look at it. And what you're going to realize is that when your angle is from 0 to 2 pi, like 0 to 360 degrees, there's going to be a couple of situations in which sine gets to negative square root of 2 over 2. And those solutions are going to be 5 pi over 4 and 7 pi over 4. You guys realize we don't include pi over 4 or 3 pi over 4 because sine is positive in quadrant 1 and quadrant 2. So you guys may remember like this unit circle. If it's pi over 4 here, sine is positive, Here, if it was 3 pi over 4, you guys realize this angle is 3 pi over 4. Again, sine is positive, so we ignore that, but we only focus on 5 pi over 4, and then this guy is going to be 7 pi over 4. So here, sine is negative. Here, sine is negative. That's why we're only picking these two guys. All right, so then are we done? We're pretty close. So one other thing we're going to do is, in order to have this to be a more general solution, we're going to add 2 pi n, or 2n pi, same deal. And then that is going to be a general solution for it, because n is always going to be general number of cycles that this function could take. Okay? All right, so I'm going to move on to my next example. So in this case, we're going to have 3 tangent squared x minus 1. All right, so we're going to find x's that make this equation true. Makes this equation true. All right, so then first thing we're going to do is we're going to isolate for that tangent function. For that, we need to add 1 to the both sides, so it'll be more simplified. So 3 tangent squared x equals 1, right? Because 1s will cancel out. So then we need to isolate for tan, so divide by 3, get rid of that 3. So tangent squared equals 1/3. Okay, great. So we're almost there, except tangent squared is, the tangent function is being squared. So then what we would do is we would simplify that a little bit, right? So what we're going to do is we're going to take the square root of this. And so that'll be something like that. That'll cancel that. So then tangent function would become tangent function. You guys realize because I'm taking the square root, I'm always going to have positive negative version. So 1/3, right? And you guys realize this is the same thing as saying plus minus square root of 1/square root of 3, right? And then because we don't like root at the bottom, we'll multiply and divide by square root of 3 and square root of 3. So then that would make it something like square root of 3 at the top and 3 at the bottom. All right, so what we're looking at is what angle x's give plus or minus square root of 3/3 for tangent, right? What x's will give you that value? So the answer to that is gonna be, you can take a look at your unit circle. Again, refer to that always. If you look at it, you're gonna realize it's gonna be either pi/6 or 5pi/6. So then answer, I'm gonna write my answer as, so there's gonna be two solutions. One, so I'm gonna call it x1. It's gonna be pi/6, plus pi times n. So I'm adding this piece because tangent has a period pi. So I'm right here. Period of tangent is pi, and for that reason we multiplied by n. Again, n is the number of cycles that we could do on a tangent function. Second solution is going to be the other x value or other angle, which is 30 degrees. So pi/6 plus pi/n again. So that would be a great answer for this problem. So next we have cotangent x times cosine squared equals 2 cotangent. So what I would prefer you to do at this point, please stop the video and try it for yourself, and then see if you find the same result as me. Why don't you pause the video and try it for yourself? Okay, hopefully you had a chance to practice this. So what I'm going to do is I'm going to go ahead and solve this equation. So first thing we're going to do is we're going to isolate functions on one side, right? So then what I want is potentially move this cotangent to the left side and see if I can simplify with the other functions. So I'm having cotangent times cosine squared x minus 2 cotangent x equals 0, right? Okay, so then you guys realize that I have two terms on the left. One has cotangent and the other one is cotangent itself as well. So what I'll do is maybe I can factor that out and see if I can do anything with the cosine and maybe potentially simplifying it in some ways. So then take that out, so cotangent x. So then I'm going to use a big parentheses here. Then I'm going to multiply cotangent by cosine squared to get the first term. Cosine squared. And then I'm going to multiply it by 2 so that I can get that -2 piece, and that whole thing is equal to 0. Perfect. So then now you guys realize that I have cotangent times cosine squared minus 2. So either of these needs to be 0 so that this equation would work. So the possibilities are either cotangent x is 0 or cosine squared x minus 2 is 0. So I need to find x's that work. So I need to find x's that make either cotangent 0 or cosine squared minus 2 0. So two possibilities. So first, let's take a look at cosine squared minus 2, because that's going to require a little bit work. So let's take a look at it. So I'm going to try to isolate cosine here. So I'm going to add 2 so that I get cosine squared x equals 2. Then I'm going to take the root so I can get just cosine itself. So plus minus root 2. So the question is, do we have any x's that make cosine plus or minus square root of 2? And the answer is no. No such angle exists. No such angle. So what that means is there is no solution. And then on the left-hand side, you notice we had cotangent equals 0. You can take a look at your unit circle, and then you'll realize cotangent is 0 when angle is 90 degrees or pi over 2. So for that reason, we're going to say x equals pi over 2. But you guys realize this could always repeat. So we might have multiple cycles of cotangent value. So for that reason, we need to add pi times n. Again, pi is because the period of cotangent is 1 pi. So it's always going to be pi times n. So that would be the only solution. So only solution for this equation. Next thing we're going to do is we're going to talk about functions involving multiple angles. What I mean by that is, sometimes you just say things like sine of x, right? Or tangent of y, right? Like one value or one variable. But sometimes you may have sine of 2x, or you may see cotangent of -5y, right? So then this just has extra component, and that brings us an extra work when it comes to solving these types. So I'm going to show you an example and show you how that will work. So an example is right here. Solve 2 cosine 3t minus 1. So you guys realize this is not, it doesn't look like a cosine x. It looks a little bit different because it's being multiplied by 3. So the variable is being multiplied by 3. So that just adds a little bit, but it's not too different than what we've been doing in this video. What I'm going to do is I'm going to solve this. So for that, I'm going to divide everything by 2. So divide everything by 2. Or wait, first we need to isolate for 2 cosine 3t, so we need to add 1 to the both sides so we can get rid of that 1. We did it right here. So we have 2 cosine 3t equals 1. Now I'm going to divide left-hand side and right-hand side by 2, so I can isolate for cosine 3t. So cosine 3t equals 1/2. So there comes the little bit challenge. So then we know that the angles that make cosine x to be 1/2 are going to be 60 degree or pi over 3 and 5 pi over 3. So then what we're going to, so let me write it here. So cosine x is 1/2 when the whole angle, the inside, is pi over 3 or 5 pi over 3. Okay, so that's what I know. But because my angle is 3 times t, then I'm going to say, well, then 3t must be pi over 3 or 5 pi over 3. And of course, we're going to add 2n pi because of the cycling situation. So then we're almost there. Because we want to find t's that make equation true, because we need just the t's, but we have 3 t's. So what we'll do is we'll divide the results by 3, and then pi over 3 becomes pi over 9, because you'll divide in by 3. That'll make it pi over 9. And then this thing becomes 2n pi over 3. And then the same thing here, divided by 3, divide this by 3. And then these are going to be my general solutions for this particular example. So hopefully that all makes sense. And that's going to be all for this video.